Good morning, everyone. Today we're going to be talking about transformations and such, basically our next activity. Hopefully this section, to be honest with you, or this particular lesson, I should say, should be extremely easy for us because knowing Algebra 2 honors, you talk about transformations, every other day pretty much. So it's going to be a lot of review and hopefully this stuff kind of comes back to you. No, instead of like an algebra where we do like a lesson each unit about transformations. This is kind of like your total sum up, where I'm basically going to show every equation, everything possible, and then talk about the transformations themselves. Now, we're going to go over some of these in class and things like that and just talk about them. But one of the key things I want you to understand in this lesson is that I'm going to show you basically the main idea. If we were really in class today, or if we really did this problem in class or this lesson, I would have you like go through, graph out all these different equations and actually try them out. But for the essence of not making you have to watch like a 40-minute video, we're going to kind of quickly go through this and then hopefully answer any questions you have about it in class. Okay. So here's what I want to talk about. Here's kind of the key concept to understand. So first and foremost, how we would have started this lesson in class is that I would basically say that these values all below here are going to be your parent functions. Okay. Just give me one moment here. There we go. So basically all these functions down here are what we call parent functions. Okay. They're the original equation. Now, in class, what we would try to do is we would actually graph all these out so you'd have a basic understanding of this. But there is a reason why we're not going to do that. Okay. The beauty of these problems that every single one of these, you could go to a calculator and just plug them in and actually get the graph. So for example, if I wanted the absolute value to see what it looks like, I could just go to my calculator, plug this in, and hit graph, and then I have my parent function that looks like this. Okay. So with that being said, with really not trying to hold up too much of your time, this is something that we could do on just an everyday basis. We could go through on a calculator or just graph by hand every single one of these functions to get the idea of what does the original look like. Okay. But that's kind of the purpose of this whole lesson. We did all of these separately in Algebra 1. Every single one of these equations we did separately within Algebra 2 last year. Okay. However, for today, we're going to kind of combine them all together and just talk about, in general, the universal idea of transformations. Okay. And so, with that being said, all I really want to do with you is give you basically an equation and then talk about how you find something to be odd or even. Okay. So the main idea that I want you to kind of bring back from algebra is that no matter what equation you have, transformations are pretty universal. And so the one equation we'd always deal with last year was negative a times b to the x minus c, and we'll just call this squared. It doesn't really have to be squared. That's just part of the function, plus d. Okay? And each and every one of those have their own specific value to them. For example, the negative causes a reflection. The a value is going to be my vertical stretch or shrink. The value of b here is going to be my horizontal stretch or shrink. C is going to be my left or right motion. So it's literally going to shift the graph. And then the key one from that one, if you always remember this, it was always opposite. And then the value of D at the end here was always your up or down motion. Okay. So the key thing to understand is that each and every one of these kind of had their own specific value to them. Okay, each and every one of them did something specific to the graph. And I'm hoping a lot of this is review from last year because you did so much of it in Algebra 2 to where I hope if I gave you an equation, you could tell me like, oh, this transformations are easy. Now, we're going to go over these in class. We're going to talk about them. We're going to go through a couple of these. But this is kind of the main idea, just understanding that any single one of these equations up here could be written out with any of these values inside of it. And that could create a different type of transformation. Okay? Now, one of the key things within this lesson is just being able to understand how to determine what an odd and even function is. Okay, because we want to be able to start to label these graphs. Okay, we can do transformations, we can do all that other stuff, but now we want to do odd and even. Okay, so I'm going to teach you how to do it mathematically and algebraically, and then I'm going to teach you basically how can you do it a very easy method. Okay, what's a very easy method you could do it with. Okay, so if I want to start off, odd and even functions are basically defined by these two values. An even function, if I were to plug a negative x in, I would get a positive answer. For this one, an odd function, if I were to plug a negative x in, my y should also become negative, okay? So really, if I'm trying to test for even or odd, I'm just going to test to see if either of these values work. So if I look at letter A here, x cubed plus 1. How this should work is I'm going to test if it's even. Keeps writing funky on me. Give me a sec here. I'm going to test if it's even or if it's odd. Okay? So how this works is if I want to test an even function, basically if I plug in a negative x, it should come out as a positive answer. So this should be f of x is going to equal negative x cubed plus 1. So the whole idea here is that if I were to plug that value in, it should stay the same. Okay. Unfortunately, though, if you cube a negative x, what's going to happen here is this is going to become f of x equals negative x cubed plus 1. Okay. The whole reason it's going to become that is because even if you were to multiply 3 negative x's in a row, it would become x cubed, but the negative wouldn't go away. It's not like a squared function where we cancel out a negative. A cube, the negative is going to stay. So notice how from the original to this equation, it changed without getting this value to become different, okay? This automatically tells me that this cannot be even. So let's try to see if it's an odd function. So in an odd function, I should have a negative on both the f of x and the x value, and I should basically see, can I get back to the original function, okay? Well, for this particular problem, if you think about this, this would become negative f of x equals negative x cubed plus 1. Okay? And I want to basically look at those and say, is this going to be a negative or a positive answer? Well, there's kind of a problem with this, right? Because if I work this out, this is going to be negative f of x equals negative x cubed plus 1. So we're close. We have a negative x and we have a negative x cubed. But let's see if I flip the signs of everything if I get back to the original. So I want to flip the signs of my negative value so if I can try to get back to this equation. Well, if I flip the signs, this would become f of x equals x cubed. And unfortunately, I would have to flip all my signs and that'd become a negative 1. So you see how once again, when I tried my mathematical way to actually solve that out, it didn't end up working. If I try to get back from the original equation from plugging those values in, unfortunately, those two don't match up. So after testing even and odd, I found out that letter A has to be neither an even or odd function. Okay? And that's basically how we test even or odd. That's an easy way to do it to actually figure out if this is a possible even or odd function. Now, there is an easy way to do this. There is a very easy way to actually solve this out. Okay? One of the methods I could teach you is looking at your exponents in each of these values. Okay? So basically, I want to focus on the exponents for all the values on this equation. So right now I have a 3. And technically, this is 1x to the 0 power because a 0 power is just going to be a 1. So technically, the x to the 0 would cancel itself out. And the easy way to look at this is to say, look at both of your exponents and basically understand, are they either both even or are they both odd? Well, 3 is odd and 0 is even. So see how they're two different types of functions? Because of that, I can automatically determine that this is neither. It can't be even, nor can it be odd. Okay? And that's one of the key things to kind of understand within this section is that I can tell if something's even or odd based off that information. Okay, I can do it in the algebraic way, like we did here, where I actually test it by plugging in a negative x for the even, and then a negative x and a negative f of x for the odd. Or I could do it this way, where I actually test each exponent in the equation. Okay? Now, just to kind of give you one more example, we'll go down here and we'll test the e value right here, x squared minus 2x. Actually, we'll do this one. We can do letter e. Okay? Let's test the even function first. So I want to see if it's even. So I'm going to plug in a negative x into each of those. So this becomes negative x squared minus 2 times negative x minus 8. And automatically, even though this first equation would become x squared, the second equation, negative 2 times the negative x, would become positive 2x minus 8. Notice how it differs from the original, so it cannot be even. We'll go ahead and try an odd function now. So for an odd function, we're going to plug in a negative f of x equals basically the same thing, negative x squared minus 2 times negative x minus 8. Well, we're going to get almost the same equation besides a negative f of x. So that's going to be equal to x squared, because the negative x would cancel because of a squared, plus 2x minus 8. And if I try to go back to the original and flip this sign, this would become f of x equals negative x squared minus 2x plus 8. So this one also doesn't work. Okay, so mathematically, I can show both of those ways of testing it to see it doesn't work. Oops. And I could also use our other method, basically our shortcut. And if I looked at this and said we have an x squared minus 2x technically to the first minus 8x to the 0. Well, we have two even functions, a 2 and a 0, mixed in with an odd function as well, which is a 1. So I can also determine that this has to be neither by doing it that way. Okay? So both methods allow me to think of an even or odd function. However, one is the algebraic way where I can actually test it. The other is just a simple check your exponents. Okay? And that's really the focus of today's lesson. Okay? Now, some of these other problems we'll talk about in class and we'll go through, but really all they are is just dealing with transformations. Okay? Understanding how it's transforming from a graph, how it's transforming from a problem and things like that. But the whole idea is just to get these main concepts down. An even or odd function, and your transformation equation, which is written on the front right here. Okay. Besides that, we'll talk to you on Monday about this. We'll go over these problems, and you have a great day.